This video is going to cover solving equations, with variable variables. I'm just going to do some examples. So I have an equation, I have an equal sign. First thing, I always draw my line in the middle. And then I look at each side independently first. Say, is there any distributing on either side? No. Are there any like terms that I can combine on either side? This side, there's not. There's 10 minus 3p. This has a p, this one doesn't, so I can't put them together. Over here, I have a 4p minus 6 plus p. I have 4 p's plus p, that's 5 p's minus 6 equals to 10 minus 3p. So now I'm trying to solve for p's, right? But I have them on both sides. So I need to get them only on one side to get an answer like p equals. See how it's alone on one side? So let's take off all of the p's from the side that has the least amount of p's. It makes it easier. So this side only has negative 3 p's, where this side has 5 p's. So which side has less p's? This one. And to get rid of them, we do the opposite, just like we've been doing with our constants and coefficients. If I have a minus 3p here, how do I cancel that? How do I get rid of it? I do the opposite. I do plus 3p. Negative 3p plus 3p goes to 0. I have 10 plus 0 left there. But what I do to this side, I have to do to the other, so I have to add 3p's here also. So then I'm left with 8p minus 6 equals 10. And then now this is 2 steps. I move my constant. And then I divide by my coefficient. So the only thing different here from multi-step, once you've simplified each side on its own, you have to get rid of the p's from one side. You have to cancel them from one side. So here's another example. So I have an equation, I have an equal sign here, and now I need to simplify each side on its own first. So let's start with this side. I have a 4 times a set of parentheses, so I need to distribute it in. 4 times 3m is 12m. 4 times plus 2 plus 8 equals. Same thing on this side. I have a 1/2 times my parentheses. So I'm going to distribute this in also. What's 1/2 times 16? 8. What's 1/2 times 24? So now I have m's on both sides. I need to get rid of the m's from one side. So I'm there's the same amount though. So you take them from either side. What am I left with? All my m's cancel. I have 8 equals 8. Does 8 equal 8? Yes, always. So this is what we call an identity. when all your variables cancel out and you have a number equal to itself, is negative. Here's my equal sign. This side is as simplified as it can get. This side, though, I have to distribute because I have a number touching instead of parentheses. This is 28 minus 7n. And so they both have the same amount, right? Let's add them again. So I get 4 equals to 28. All my variables cancel. But does 4 equal 28? No. They're not the same. So this type of answer is called a no solution problem. So another example where we do have a solution. 2u minus 9 equals 2 times 2u plus 6 plus 5. So now, there's my equal sign. I have this side is simplified as it can get 2u minus 9. Yes. I have distributive property. I have to do this side. 2 times 2u is 4u. And then 2 times 6 is positive 12. Then I have a plus here. So again, this side is as simplified as I can get it. On this side, I have like terms that I can put together. I can put a 4u plus u gives me 5u's plus 12. And now, each side is as simplified as it can get. Now I look at it as a whole. This side equal to this side. So which side has the least amount of u's to take off? Over here. If I have positive 2u, I'm going to take over 2u. And I'm left with negative 9. But if I take 2u away from here, I need to take it away from here also. And that's what I get. So now, I'm trying to solve for u. I have 1u on one side of my equation, which is what I want. Now I move my constant. So this is negative 21 plus 3u. There's the answer.